Hello, my dear students. Hope you all are healthy, fine, and at the top of your mood. Now, let us proceed to the next part of the next topic of the chapter. Chapter is linear equations in two variables. By now, you have understood how to solve the linear equations in two variables. Okay, how to solve you have understood. You have understood different methods by which you can solve the linear equation in two variables. In total, there are four, as you know. Substitution method, which is the most basic method, then equating coefficient method, then graphical method, and then cross multiplication method or the Kramer's rule method. Certain important things if we revise in linear equation in two variables is that, dear students, each equation, I'm talking about each equation, actually which is linear equation in two variables. Each equation can be presented in a form of a graph. Okay, we can draw a graph of each equation. You must have seen by now. And then what we do is that basically when we have a graph, when we draw a graph of one equation, and then we draw a graph of another equation, when the two graphs, they are drawn, my dear students, you have to understand that when you draw the two graphs, there are three conditions possible. Three different conditions that are possible when you draw a graph. When you draw a graph, there are three different conditions possible. What are the three different conditions? I have used a lot of space. See, what are the three conditions? Either you will have, see, graph means what I am talking about when you have got two equations, equation 1, equation 2. When you have got two equations, you will be drawing the graph of both the equations, equation 1 and equation 2. When you draw, when you draw a graph of one equation and you draw a graph of second equation, then you can have intersecting graphs. Like this, the graph will be intersecting each other, or you will have the two graphs which are parallel to each other. They can be like this also. Is it not necessary that they can be parallel also? Is it necessary that they will be only intersecting every time? No. If we have this equation 1 and equation 2, the two graphs, it is very much possible that the two graphs will run parallel to each other without intersecting in each other. They can be in any direction, parallel to each other. Fine. Otherwise, one more interesting thing can happen. See, if I draw one graph, one equation, and I draw another equation, they basically are overlapping each other. The graphs will be overlapping each other. They will overlap each other. You can have intersecting graphs. You can have parallel graphs. You can have coinciding or overlapping graphs. Okay, these are the three conditions possible, my dear students. Try to understand the three conditions. Either the graph will intersect each other and intersect at only one point. At that time, this intersecting point is a solution. Or they will be parallel to each other. They will be having no intersecting point. In case there is no solution. Here, one solution, here no solution, because there is no intersecting point. And here there are, because they are intersecting everywhere, they are overlapping, they are running over each other. That means they are intersecting at each and every point. So here there will be infinite solutions. Are you getting, my dear students? These are the things that are happening. You have to understand this, that when you have got two equations, when you have got linear equations in two variables, means you have got two simultaneous equations. When you have two simultaneous equation, equation 1, equation 2, then there are three things possible when you talk about these two equations. One is either they will be having only one solution, or they will be having infinite number of solutions, or they will be having no solution. You understand the meaning of no solution? No solution means there is no value of x and y which will be satisfying both the equations simultaneously. There is no solution, there is no value existing which will satisfy equation 1 also, and then the same value will satisfy equation 2 also. This is not going to happen. That's why we call it no solution. In this case, these equations are called as consistent equations because they have a solution. One solution, but they have a solution. Consistent equations. Here they are definitely consistent again, dependent consistent equations again, and these are not consistent or inconsistent. Equations because they don't have any solution. Are you getting, my dear student? This is basically the picture that you have to understand, and that is mainly why graphical method is very important, because to understand this, whether the solutions are existing, and if they are not existing, then why are they not existing, and if they are existing only in one solution form, or they have got infinite number of solution form, graphical method is very easy to understand. Because they are parallel graphs, because they are the lines who are running parallel to each other, that's why they will not have any value of x and y which can satisfy this equation and this equation. Of course, one value of x and y which will be satisfying this equation and another value of x and y which will satisfy this equation is possible, but that is not called as the solution of the two simultaneous equations. Solution means what? Same value of x, same value of y is going to satisfy both the equations. Then we say this is the solution. But this is not going to happen in this case. Now the question is, can I, without solving the two equations, can I make out whether the equations will be having a solution, will be having infinite solutions, will be having no solution? Is it possible to understand that? Yes, my dear student, that is the next topic that we have to understand. That yes, we can definitely, without solving the questions, without actually solving the questions, we can definitely conclude, or we can definitely make out that the two equations, first equation general form a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. In this case, again, you can have any general form. You can have this general form, or you can have a1x plus b1y is equal to c1, a2x plus b2y is equal to c2. Will not make any difference. This is the first equation, this is the second equation. Okay, in this case also, remember, this is going to make a difference in Kramer's rule method, in cross multiplication method. At that time, this is definitely going to make a big difference. Because the formula changes. When you use this way, the formula is different. When you use this way, the formula is different. Otherwise, no other part of the chapter, this general form is going to make any difference, and not even in this case. So how do you identify when the two equations are given? Now let us return to the topic. When the two equations are given, how do I identify whether the two equations will be having one solution, will be having infinite number of solutions, or will be having no solutions? Means they will be intersecting lines, one solution, they will be overlapping lines, infinite number of solutions, or they will be parallel lines having no solution. Okay, my dear students, this is what you have to understand. So if we have to understand, then what is the procedure that we have to go through? See, my dear student, the two equations are like this: a1x plus b1y plus c1 is equal to 0. What you have to do that? You have to, once after comparison, comparing the two equations, you will be getting a1, a2, b1, b2, c1, c2. Okay. What you have to do first, you have to calculate a1 upon a2. Whatever is the coefficient of x of first equation, coefficient of x of second equation, you have to find the ratio of that. Once you find the ratio of this, then you will find the ratio of b1, b2. Means the coefficients of y in first equation, coefficient of y in the second equation, find the ratio of this. By here, the comparing over here itself, you'll understand whether a1 upon a2 and b1 upon b2 are equal or not. If they are not equal, if a1 upon a2 and b1 upon b2 is not equal to each other, then they are intersecting lines. They have one solution, that's all. And you don't have to consider anything else. That is because they are intersecting lines. Now, because they are two intersecting lines, now the question of parallel lines and the question of coinciding lines doesn't appear. They are intersecting lines. Remember, what you have to do, find the value of a1 upon a2, find the value of b1 upon b2, and compare the two. If they are not equal, either of the two is going to happen. Either they will be equal or they will not be equal. Even if they are not equal by signs, remember, even if they are not equal by signs, supposing a1 upon a2, I get a1 upon a2 is equal to 7 upon 3, and I get b1 upon b2 is equal to minus 7 upon 3. They are still not equal. So a1 upon a2 is not equal to b1 upon b2, because plus 7 upon 3 minus 7 upon 3 are different values. So then in that case also, they have one solution. They are intersecting lines. Now let us go to the second topic. The second topic is they will be equal. If a1 upon a2 is equal to b1 upon b2, then find c1 upon c2. Now you will have to calculate this, c1 upon c2. This you will have to calculate. Now again you compare a1 upon a2, b1 upon b2 and c1 upon c2. And definitely what will happen, again two conditions, a1 upon a2 is equal to b1 upon b2, definite, but it is not equal to c1 upon c2. Means c1 upon c2 is totally different ratio. It is not equal to this. If this is the case, then they are parallel lines. They have no solution. Okay? They don't have any solution because they are parallel lines. This is the formula that you have to remember. a1 upon a2, if a1 upon a2 is not equal to b1 upon b2, means coefficient of x, the ratio of the coefficient of x is not equal to the ratio of the coefficient of y. Ratio of the coefficient of one variable is not equal to ratio of the coefficient of second variable. They are not equal. That means the two lines are intersecting lines. They have one solution. Okay, chapter close. But if ratio of coefficient of one variable is not equal to the ratio of the coefficient of second variable, then you will have to find the ratio of constants. Now again the condition will be same. Either the two ratios will be equal to C1 upon ratio of C1 upon C2, or they will not be equal to ratio of C1 upon C2. If they are not equal to the ratio of C1 upon C2, then they are parallel lines. You have to make out that they are parallel lines. They have no solution, or we can say they are inconsistent lines. They are consistent lines. See, these all are same meaning. From this, these three conditions can be derived. From this, the three condition can be derived. They will ask you, identify whether the given equations are inconsistent or not consistent, or consistent, inconsistent or consistent. At that time also you have to do this comparison. They will ask you whether they have got solution or no solution. Still you will have to do this comparison and answer it. Now of course, the second condition what? If a1 upon a2, the ratio of the coefficients of first variable is equal to the ratio of the coefficient of the second variable and is also equal to the ratio of the constants, then they are coinciding lines or overlapping lines. They have infinite solutions. Consistent, dependent is also there. They are consistent lines, or in comma bracket normally they are dependent, because they basically are dependent on each other. This is the topic that we have to understand when we have to solve the next part of the questions. Okay, fine, my dear students. Actually, we can enter into exercise 3.2 for this. See, basically your chapter starts with exercise 3.1, but there they are starting with word problems. In question number 1 of 3.2 also they are starting with word problems. But this is what I will not like to start with. Word problems, I will start all of them together. Of course, exercise 3.2, second question onwards, we can definitely start. And then you will be able to see what is happening. Okay, my dear students. So, let us start with the exercise 3.2. Question number 2. Question number 2. Here what are they asking is that on comparing the ratios a1 upon a2, b1 upon b2 and c1 upon c2, find out whether the lines representing the following pairs of linear equation intersect at a point. Do they intersect at a point, are parallel or are coincident? Okay, what type of lines are they? They are intersecting lines, they intersect at a point, they are parallel lines, or they are coincident lines. So here the first question we start with. What is it? 5x minus 4y plus 8 is equal to 0 is your first equation. Second is 7x plus 6y minus 9 is equal to 0. Second. Now you can say, comparing with a1x plus b1y plus C1 is equal to 0. A2x plus B2y plus C2 is equal to 0. A1 is equal to 5, B1 is equal to -4, C1 is equal to 8, A2 is equal to 7, B2 is equal to 6, C2 is equal to -9. Okay, this we have got. Then A1 upon A2 is equal to 5 upon 7, this is your 3. B1 upon B2 is equal to -4 upon 6, that is equal to -2 upon 3. Now you can make out from 3 and 4, A1 upon A2 is not equal to B1 upon B2. So we can make out they are definitely not equal. So when they are not equal, when A1 upon A2 is not equal to B1 upon B2, that itself the solution gets over. No need of calculating C1 upon C2. So here we can say therefore the lines, because they are asking you whether the lines representing the following pairs. So you will tell therefore the lines intersect at a point. Answer what they are asking. Okay, it depends. See, there are many questions here. What are they asking? Whether the following pair of linear equations are consistent or inconsistent. At that time, after comparison, doing the same comparison, if the same question, same lines would have been there, the A1 upon A2 is not equal to B1 upon B2, I would have told that they are consistent. Who are consistent? Following pair of lines are following pair of linear equations. The following, not lines. Here there is no lines and everything. Following pair of linear equations are consistent. Okay, here also the same, are consistent or inconsistent. If consistent, obtain the solution graphically. Means you will have to draw the solution. We will have to solve the solution graphically. Okay, graphically we will have to draw the solution. That is the thing. Okay, my dear students. So likewise, now we will go to the second question. Second question is, what is the second question? I better go to the next paper, otherwise half either. Second is 9x plus 3y plus 12. Is equal to 0. This is the first equation. 18x plus 6y plus 24. Now you will see, my dear students, are you able to notice something? See, if you will notice, if I multiply this equation by 2, 2 9s are 18, 2 3s are 6, 2 12s are 24. Basically, they are same equation. That is, now this is going to be a coinciding lines. Are you getting? Usually when you will be able to see that this, when you multiply the first equation by 2, you are going to get the second equation. So here, now here you will do the same thing. Comparing equation 1 with A1x plus B1y plus C1 is equal to 0 and equation 2. Fine. Therefore, A1 upon A2 will be equal to what? 9 upon 18, that will be equal to 9 1s are 9 2s are. Fine. Now B1 upon B2 is equal to 3 upon 6, that is equal to 3 1s are 3 2s are. Now you can make out here itself that you are going to get A1 upon A2 is equal to B1 upon B2. So now itself you can continue and calculate C1 upon C2, keep it ready. So C1 upon C2 is equal to 12 upon 24, that will be 12 ones are 12 to 7. Now you can say from 3, 4 and 5 we see that, not we get, we see that A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. They are all equal. Therefore, the lines are coincident. Okay, they are coincident lines. Okay, fine. Hope you all are getting this. This is quite easy. Now I'll ask you all people to try with the third question on your own. Just pause the video and solve the third question. Once you have finished, then you can resume the video. Okay, so first equation, 2x minus y plus 9 is equal to 0 is the second equation. A2 is equal to here 2 minus 1, 9. 2, B2 is equal to minus 1, C2 is equal to 9. Okay, so we get A1 upon A2, 6 upon 2, that is 2 3s are 6, 2 1s are 2, 3 upon 1 you will get B1 upon minus 3 upon minus 1, minus minus plus, so it will be 3 upon 1. These both are equal. Because these both are equal, I will have to calculate C1 upon C2 is equal to 10 upon 9. This is not, I can't divide this, this is not reducible, so this is 10. So now I will say from 1, 2, 3, oh not 1, 2, 3, this is 3, 4, 5. 3, 4, 5. We see what? A1 upon A2 is equal to B1 upon B2. But it is not equal to C1 upon C2. Therefore, the lines are parallel. Okay, they are parallel because this is the condition. Okay, my dear students, so hope you all are understanding this topic. Very easy topic. The introduction part is done in this way to identify whether the solutions exist or not. Question number 3, if you will see, on comparing the ratios A1 upon A2, B1 upon B2 and C1 upon C2, find out whether the following pair of linear equations are consistent or inconsistent. Only this much you have to understand. Same thing, first equation is 3x plus 2y is equal to 5. Nothing, no problem, you can take it in this fashion also. And 2x minus 3y is equal to 7. Same thing we will do comparing equation 1. Okay, dear students, this is not going to make any difference because see, basically if 5 and 7 would have been here, it would be minus 5, minus 7. And when you will find the ratio of minus 5 upon minus 7, it will be still minus minus plus 5 upon 7. It is not going to make any difference. So here now we will get a1 3 upon 2. This is your third. b1 upon b2 is going to be equal to minus 2 upon 3. Definitely they are not equal. You can make out 3 upon 2 and plus 2 upon minus 3 will be minus 2 upon 3. So they are not equal. So here no relation of c1 upon c2. So you will get from 3 and 4. We get, what do we get? a1 upon a2 is not equal to b1 upon b2. They are not equal. Therefore, they are asking us the pair of linear equations are consistent or inconsistent. Therefore, the pair of linear equations are consistent. Remember, intersecting lines, overlapping lines, both are consistent. Okay, then we go to question number 3 ka first one was this. Question number 3 ka second one. 2x minus 3y is equal to 8. Okay, fine. This is my first, and then 4x minus 6y is equal to 9. 2 2s are 4, 2 3s are 6, 2 8s are 16 should have been there. Then they would have been consistent. They would have been coinciding lines, but now they are not. So here what you will get now, again the same thing, comparing equation 1 with a1x plus so we will get a1 upon three minus 3 upon minus 6 minus minus plus 3 1s are 3, 3 2s are 6. These both are equal. This I cannot reduce. So what? a1 upon a2 is definitely equal to b1 upon b2, but it is not equal to c1 upon c2. Therefore, the given pair of linear equations are inconsistent. Okay, fine. So we have done with second question. Now we can go for question number 3. Now here if you'll see, we are not interested in having denominators. So what we can calculate like that also, taking a1 is equal to 3 upon 2, then a1 upon a2 will be 3 upon 2 divided by something. But if you want, we can just take out this. Why do we have this? So multiplying throughout by what? 2 denominators, 2 3. The LCM of 2 3 is 6. This will give me 3 3s are 9x, 2 5s are 10y, 42. Okay. This will be your first. Going to the second one, 9x minus 10y is equal to 14. This is my second. Now the same thing I'll do. You can just pause the video, carry on. You'll get a1 upon a2 is equal to 9 upon 9, that is equal to 1 upon 1. What is this? b1 upon b2 is equal to 10 upon minus 10 is equal to minus 1. Now here they are definitely not equal. a1 upon a2 is not equal to b1 upon b2, but the signs are different. One is positive, the one is negative. They are definitely opposite numbers. So therefore the given pair of linear equations are consistent. Okay, this is what they have asked us to compare whether they are consistent or inconsistent. Now we go to question number 4. First is 5x minus 3y is equal to 11. Next is minus 10x plus 6y minus 22. This is interesting because this is multiplying by 2, but then it is becoming minus. This is multiplying by minus 2, my dear students. This is first equation is getting multiplied by minus 2. Minus 2 into 5 will give you minus 10. Minus 2 into minus 3 will give you 6. Minus 2 into 11 will give you minus 22. This should be coinciding lines. Okay, so here so we will do a1 upon a2 is equal to 5 upon minus 10. That will be 5 1s are 5, 5 2s are 10, minus 1 upon 2. Fine. Then minus 3 upon 6, minus 3 1s are 3, this also minus 1 upon 2. Fine. Then 11 upon minus 22. 11 1s are 11, 11 2s are plus minus minus 1 upon. So a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So therefore the given pair of linear equations are, they all are equal, so they will be coincident, and all the coincident are consistent. Only parallel lines are inconsistent. So because they are coinciding lines, they all will be consistent. Okay, my dear students, now next one is fifth question. We will try doing it with the technique of 4 upon 3 only. 4 upon 3x plus 2y is equal to 8. This is your first equation. And you have got 2x plus 3y is equal to 12 is your second equation. Same thing you will tell comparing equation 1 a1 is equal to 4 upon 3, b1 is equal to 2, c1 is equal to 8, a2 is equal to 2, b2 is equal to 3, c2 is equal to 12. So a1 upon a2, what is a1? 4 upon 3. What is a2? 2. So 2 upon 1, it will become 1 upon 2. Are you getting? This is 2 upon 1. When I am writing this in the denominator, it will become 1 upon 2. So this will become 2 ones are 2 upon 3. Fine. And is equal to 2 upon 3 straight. And is equal to 8 upon 12, right? As C1 upon C2. 8 upon 12. 4 2s are 8, 4 3s are 12. So what do we get? A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. They all are equal. Therefore, the given pair of linear equations, they all are equal. So they are coincident. Because they are coincident, consistent. Okay, with this we finish question number 3. And now we go to question number 4. Word problems, my dear students, will be doing together. Okay, again the same thing. Which of the following pair of linear equations are consistent, inconsistent? If consistent, obtain the solution graphically. Okay, this is question number 4. And here they are telling, of course, first one, x plus y is equal to 5. Now we can speed up. 2x plus 2y is equal to 10. See, they are going to be consistent 2, 2, 2. So we will have to draw the graph of this. Okay, so here what I'll get? A1 is equal to 1, B1 also is equal to 1, and C1 is equal to 5. A2 is equal to 2, B2 is equal to 2, and C2 is equal to 10. So, fine. So, they are all equal. Therefore, they are consistent. So now I will have to get the graph book. Why was I out always? Where is the graph book? Graph book. So here is our graph book. Okay, I'll not use this pen. If I don't use this pen, then which one do I use? Of course, we will require the two equations to solve again. Uh, should have. Okay. First, I have to solve the graph. I did not keep this things ready. 1, 2, 3, 4, 5, 6, 7, 8. So, when I have to solve this equation first, then what I have to do? First, I have to see to it. First equation is x plus y is equal to 3. You have to solve them by graphical method. So equation 1, x plus y is equal to 5. So you get x is equal to 5 minus y. You can take any one, nothing problem. So I'll make a table with 4 columns, 3 rows. So you can get it over here itself, f x plus y, x is equal to 5 minus y. So here for y is equal to 0, I will get x is equal to 5 minus 0, so you will get x is equal to 5. Okay, for y is equal to 0, you will get x is equal to 5, 5 comma 0. For y is equal to 3, fine, x is equal to 5 minus y, 5 minus 3, x is equal to 2. For y is equal to 3, you get x is equal to 2, 2 comma 3. For y is equal to, I will take minus 3, x is equal to 5, minus will be plus 3, x is equal to 8. So y is equal to minus 3, x is equal to 8. This is 8 comma minus 3. So your first table is ready, but I will require to make it for the second is 2x plus 2y is equal to 10. Second equation, 2x plus 2y is equal to 10 is my second equation. So now if I have to find this, though, 2x is equal to 10 minus 2y, x is equal to 10 minus 2y upon 2. Okay, here actually speaking, I can solve this. I can take out 2 as common factor and solve it, my dear students. This can be done, and you will be anyhow getting the same values. So, but still, just to keep the suspense intact, anyhow you will be getting the same values, my dear students. X, y, x comma y. So here for y is equal to, supposing 0, x is equal to 10 minus 2y upon 2 it is going to be the same value. So there is no point, don't take it as, now better we don't keep the same values. For y is equal to 0, x is equal to 5. For, we will not take the same values now, otherwise the plotting will be, y is equal to 3 we have taken second time, na? Y is equal to 3, so we will do one thing, we will take y is equal to 2. So this will become 3. Fine. For y is equal to 2, x is equal to 3. So in this way we will be having different figures. It is 2, 3, it is 3, 2. Fine. So next I have taken y is equal to minus 3, though I will go for y is equal to, if I go for 3, so it will be same. 4 2s are 8, minus 2, okay fine, 4. So x is equal to 10 minus 2y by 2, 10 minus 2 into 4 by 2, 2 4 is 8 by 2, 2 by 2, x is equal to 1. So for a y is equal to 4, you will get x is equal to 1. Fine. Now if I proceed to plot the two lines, first one is 5 comma 0, means on x-axis 0, this is 5 comma 0. Second one is 2 comma 3, 2 over here and 3 over here, fine. Third one is 8 comma minus 3, means 8 over here minus 3 over here on the y-axis. See, you can see definitely this is a straight line, undoubtedly, there is no doubt regarding that. But now if you will see the other 3 points, they will come on the same line anyhow. 5 comma 0, this is again 5 comma 0 is the same. This was 2 comma 3. This was 8 comma minus 3. And now the next one is 3 comma 2, means 3 over here and 2 over here. See, 3 comma 2, and then we have got 1 comma 4, 1 comma 4. Basically they are overlapping lines. Fine. So likewise we see that they are going through the same thing. So now let us proceed with the exercise. which demands us to solve the. So we have found that if the consistent obtain the solution graphically. So what is the solution graphically here? Since the lines are coincident, the solutions are infinite. You can take for example 5, 0, anybody, 5, 0, 3, 2, 2, 3 are the solutions, are few of them. Fine. There are plenty. Out of that 3 I have given. I saw the both sare aayenge. Fine. Now going to question number 2. X minus y is equal to 8. Your first question. 3x minus 3y is equal to 16 is your second equation. Again the same thing you will be doing now. Comparing equation 1 with a1x plus b1y is equal to c1 and equation 2 with a2x plus b2y is equal to c2. a1 is equal to 1, b1 is equal to -1, c1 is equal to 8. Fine. 1 minus 1, 8. a2 is equal to 3, b2 is equal to -3, c2 is equal to 16. a1 upon a2 will be equal to 1 upon 3. b1 upon b2 will be equal to -1 upon -3. That will be still 1 upon 3. So basically we can see that they both are equal, 1 upon 3, 1 upon 3. So c1 upon c2 will be mandatory to be solved. 8 upon 16. 8 1s are 8, 8 2s are 16, but they are not equal. So from 3, 4, 5 we see, what do we see? a1 upon a2 is definitely equal to b1 upon b2, but it is not equal to c1 upon c2. Therefore the given pair of linear equation is inconsistent. Okay, they are inconsistent. So that is done. So second also is over. So now going to the third question. So when we go to the third question, 2x plus y, this also we can keep it in the same fashion, no problem. 2x plus y minus 6 is equal to 0 and 4x minus 2y minus 4 is equal to 0. You don't have to take any problem. Comparing equation 1 with a1x plus b1y plus c1 is equal to 0 and equation 2 with a2x plus b2y plus c2 is equal to 0. a1 is equal to, this is a1, 2, b2 is equal to plus 1, c2 is equal to minus 6. Sorry, c2, a1, b1, c1, sorry, a2 is equal to 4, b2 is equal to minus 2, c2 is equal to minus 4. So a1 upon a2 is equal to 2 upon 4, that will be 1 upon 2. 1 upon 2, b1 upon b2 is equal to 1 upon minus 2, that will be minus 1 upon. So here itself we can see that they are not equal. One is positive, the other one is negative. They are definitely not equal. So 1 and 2 we see a1 upon a2 is not equal to b1 upon b2. Therefore, the given pair of linear equation is consistent. Now the next step is to solve the equations. So for that, first equation, 2x plus y minus 6 is equal to 0. 2x plus y minus 6 is equal to 0. But this time now, because I have to solve it by, so here y I have to find alone, because coefficient 2 is there. So this will go on the other side, 6 will go on the other side, 6 minus 2x. Fine. This is equation 1. 6 minus 2x. So now I will have to make a table, 4 columns, 3 rows, x, y, x comma y. So here x is equal to 0. Fine. For x is equal to 0, y is equal to 6. Now I will take this as 2. If I take, it will be a nice number. X is equal to 2, y is equal to 6 minus 2x. Fourth, I will get y is equal to 2. X is equal to 2, y is equal to 2. And just to make the equation, if I go to make it, that will reach to 10. 10, it's okay, fine. For x is equal to minus 2. For x is equal to minus 2, y will be equal to 10. This we have done for first equation. For second equation is 4x minus 2y minus 4. Okay, is that right? Okay, so I'll get over here. If I have to get it, then see, minus 2y is equal to minus 4x plus 4. Are you getting? 4x has shifted over there, minus 4 has shifted over there. But then I want this to be plus 2y. I'll shift all the signs. 4x minus 4. Are you getting? I want this to be plus, so this also every sign will be changed. Now I'll write y is equal to 4x minus 4 upon 2. Here also I can solve it further. Y is equal to 4 can come out as a common factor. X minus 1 upon 2. Are you getting? This goes as a common factor. This will be 2 1s are 2, 2 2s are 4. I'll get y is equal to 2 into x minus 1. That is y is equal to 2x minus 2. This is better. So again the same thing I'll do. This is x, y, x comma y. First I will take this as x is equal to 0. So for x is equal to 0, I will substitute directly. Y is equal to 2 into 0 minus 2. Y is equal to 0 minus 2. Y is equal to minus 2. For x is equal to 0, y is equal to minus 2. This will be 0 comma minus 2. Now I go for x is equal to 1. 2 into 1 minus 2, 0. X is equal to 1, y is equal to 0. For x is equal to, now what do I do? 2 लेता हूँ, x is equal to 2. Fine. X is equal to 2. क्या हो रहा है? ठीक है, y is equal to 2. This is the solution. 2 comma 2 is going to be the solution because they are intersecting over there. Okay, my dear students, so now I go to keep my graph paper ready. I'm sorry I have not kept them ready. I should have kept them. I was not expecting these questions. I was not expecting graph over here. Otherwise, I would have kept this ready, my dear students. I'm really sorry for this. Otherwise, I would have definitely kept them ready. 1, 2, 3, 4, 5, 6, 7, 8, 9, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Fine, so here our graph is ready, my dear students. So now graph means our coordinate system is ready, not the graph. Okay, 0, 6, 2 by 2, 0, 6 means on y-axis 6. Next is 2, 2, 2, 2 is this. Fine. Then it is minus 2, 10. Minus 2 is over here and 10 goes up. This is a straight line. These all colors I am drawing for you all people to understand. You all people are not supposed to draw like this. The graph was 2x plus y by the 6. This I should have written in the end. So now 0, minus 2 means y-axis minus 2. Y-axis minus 2. Fine. 1, 0 means x-axis 1. 2, 2 is this. Fine. So now if I draw this, the graph will run straight like that, and this is their point of solution. 2, 2. Okay. So 2, 2, x is equal to 2, y is equal to 2 is the solution. So that is what I will write over here. I don't have space to write over here, but then you have to write it over here, or solution of given pair of linear equation is x is equal to 2. Okay, fine. So in this way we have gone through and through and through question number 3. Question number 4. Okay. In question number 4, what do we have? 2x minus 2y minus 2 is equal to 0. This is 2x minus 2y minus 2 is equal to 0. First equation. Second is 4x minus 4y minus 5 is equal to 0. So now again we will do the same thing, comparing equation 1. a1x plus b1y plus c1 is equal to 0, and equation 2, a2x plus b2y plus c2 is equal to 0. a1 is equal to 2, b1 is equal to minus 2, c1 is equal to minus 2. a2 is equal to 4, b2 is equal to minus 4, c2 is equal to minus 5. So you get a1 upon a2 is equal to 2 upon 4 is equal to 1 upon 2. b1 upon b2 is equal to minus 2 upon minus 4 is equal to 1 upon 2. Fine. And c1 upon c2 is equal to minus 2 upon minus 5 is equal to 2 upon 5. This is 1, this is 2, this is 3. Oh, this is 3, this is 4. 3, 4, and 5. See what? a1 upon a2 is equal to b1 upon b2, but it is not equal to c1 upon c2. Therefore, the given pair of linear equation are inconsistent because they are parallel lines. Okay, my dear students, so in this way we have finished with question number 4. So one thing I'll do, we will stop over here after question number 4. 5, 6, 7 we will do later. Okay, 5 is definitely word problem, we will be doing afterwards. 6 and 7 are slightly different terms, so we will do them together. Okay, my dear students, thank you very much. See you all soon. Stay happy.